Welcome back, ladies and gentlemen. In this very short video, we are going to be discussing the corollary. Now remember, a corollary is simply what I call an add-on to a theorem. It's a kind of separate theorem that is easily proven by the original theorem. So our corollary that we're going to talk about here today is the base angles corollary and the converse corollary. Simply put, I'm going to try to make this as easy as possible. If all of the angles are congruent, all of the sides are congruent. If all the sides are congruent, then all the angles are congruent. So if it's an equilateral triangle, you end up having an equiangular triangle, or vice versa. Okay? Now, why does this ends up being beneficial? Well, it comes beneficial in proof, but it also comes beneficial in examples like this. It says find the measure of angle P, angle Q, and angle R. Let's think about this. The triangle sum theorem, all right, states all triangles, interior angles add to 180 degrees. Well, what did our corollary of our base angles theorem tells us? If it's equilateral, then it's equiangular. Every single one of these angles are congruent to one another. So what if I called that angle X, and that angle X? And at this point, you may be already watching being like, Mr. McGuckin, I get it. I know what it's going to be. But just bear with me for a sec. This will be useful to know how to set up these equations in the future. So if each one of these are X, why X? Because they're all the same thing. Triangle sum theorem says they have to add up to 180. X plus X plus X gives me 3X. Dividing through, we get 60 degrees. So I could say that angle P, angle Q, and angle R are all 60 degrees. So that is a very basic use of our corollary to the base angles theorem, but there are plenty of other applications that this one picture can be used in multiple different ways. I want to make sure that we talk about it a little bit. All right, on to the next one.